Hello everyone and welcome to Flying Ants Academy. So in today's lecture, we will be talking about logical thinking and problem solving skills for writing computer programs. Now even before you start writing programs or start actual coding, one has to understand the basic of how to tackle a problem or how to approach a problem, right? Any particular problem will have multiple solutions, or maybe some problem will have just one way of solutions. Most of the problems that we have, there are more than one ways to tackle it. Similarly, also in terms of computer science or when you're writing programs, there will be multiple ways in which you can solve a problem. So now our aim should be to find the optimal way, first of all, or to actually understand what are the various ways to solve a problem or how to tackle it, how to go about it, how to develop that thinking when we get a problem, how to approach the problem, and how to tackle and solve the problem. Once we have that in our mind clear, then it will be very easy to transform it into code. You cannot just have a problem statement then directly start writing code. One has to really understand it, have the logic clear in his or her head, and then you can actually go out and tackle the problem well. So let's dive in, and I'll take a couple of examples and I'll show you how to break down a problem and how to really go about it. So let's dive in. Okay, so for our first example, let's say we want to find out if a number is even or odd. So you must be aware that even numbers are like 2, 4, 6, 8, and so on. So these are all called even numbers. And odd numbers are like 1, 3, 7, 9. So how do you know that a number is even? What logic will you apply? Like before writing the program, what logic will you apply in your mind that this number is even or not? So it's quite simple, I guess, if you know basic maths. Like I told, basic math is required. So for us to find out if a number is even or not, what we're going to do is, or what we are supposed to do is, we're going to divide that number, by 2, right? So if we like say divide 2 by 2, it's 1, and the remainder is 0, right? The remainder is equal to 0. Now 4 divided by 2 is equal to 2, and again this remainder is equal to 0. Now 102 divided by 2, for example, it's 51, and again the remainder is 0. So we see a common practice over here. Now let's say if we have 3 divided by 2. So 3 divided by 2 would of course be 1.5 if we are using decimal. If we are just using normal, it would be 1, and the remainder would be 1, right? The remainder of 3 divided by 2 would be 1. Similarly, 123 divided by 2, the remainder would be 1. So we see a very common thing over here, right? For every even number, 2, 4, 6, 8, 10, and so on, for every even number, the remainder is always 0 when divided by 2, right? When we divide any even number by 2, the remainder will always be 0. And when we divide any odd number by 2, the remainder will always be 1. So now we have a logic clear. So this is how we tackle a problem. Our problem was to find whether a number is even or odd. So now we know if we divide that number by 2, if the remainder is 0, we know that the number is even. If the remainder is 1, we know that the number is odd. So with this one simple logic, you can have multiple ways of writing a program. So let's say we are given a problem statement to find out if a given number is even or not. Let's say we are given a number 168, for example. We want to find it if it's even or not. So very simple, because from this logic we know we just have to divide this number by 2. If we get the remainder is equal to 0, which in this case is, if the remainder is 0, then of course we know that this is an even number. Otherwise this is not an even number. Okay, so now let's take one more example. Let's see if we want to find out whether a number is prime or not. Now, for those of you who are not aware of it, a prime number is a number which is only divisible by 1 and itself. Well, you got to pardon my handwriting because I mostly write code. So obviously it will be much better when I type the code, and this comes out to be very bad. So anyway, coming back to the logic. So a prime number is a number which is only divisible by 1 and itself. It means it is not divisible by any other number between it. Okay, so from our previous logic, it is very clear that if a number is even, it cannot be a prime number. Why? Because if a number is even, it will always be divisible by 2. And by logic, a prime number is only numbers that are divisible by 1 or itself. But is this the complete logic? If you go and say, okay, if a number is not divisible by 2, that means it's prime. Well, no, not really. Because if we take an example of 21, this is an odd number, but it is not a prime. 21 is divisible by 3. The answer is 7 and the remainder is 0. Okay, similarly, you can go for 15. Like 15 is an odd number, but it is again divisible by 3. 15 is also divisible by 5. Because in both these cases, remainder is equal to 0. Again, no need to think about writing any kind of code. Just try to understand how can we find out if a number is prime or not. When we know these things, when you know these things, that a prime number is only divisible by 1 and itself. Divisible as in, if you divide the number by 1 and itself, the remainder will be 0. But obviously, any number is divisible by itself and any number is divisible by 1. But if you divide it by any other number, the remainder will never be 0. So we know this thing. We also know that all even numbers are not prime numbers. So there can be multiple logic for this. Now let's say if we want to check if a given number is prime or not. So what we can do, let's say we take an example again. We take an example of 21. So what we can do is, we can start dividing 21 from 2, right? From 2 to 20 to be safe. We cannot include 1 and we cannot include number itself. So in this case, if the number is 21, then 1 and 21 is always divisible. So 21 will always be divisible by 1 and 21. Of course, the answer will be 21 and 1 in this case. So we have to check if the number is divisible by 2. So 21 by 2, no, because it would be like 10.5. We have a remainder. 21 by 3, yes, 7. 21 by 4, again no, because it's around 5 point something. 21 by 5, again 4 point something, right? So in this case, we know that 21 is divisible by 3, hence it cannot be a prime, because between these two numbers, between 1 and 21, there is one number by which when we divide the given number by that number, we will get remainder is equal to 0. Okay, so let's say we take an example of another number which is 23. Same logic, we'll start dividing 23 by every number from 20 to 22, which is 1 less than this number. So 2 to 22. Now if you see, if you go to 23 by 2, it would be 11 point something. 23 by 3, it would be 7 point something. 23 by 4, it would be 5 point something. 23 by 5, it would be 4 point something. 23 by 6, it would be 3 point something. So if we keep on going from 2 to 22, we will find out that there will not be any number which will give remainder is equal to 0. Not. So 23 is equal to prime. So the conclusion that we come over, first of all, any number which is even is not a prime. That's okay. We can use this in our coding or we cannot use this in our coding. Anyway, so logic would be like, if we are given a number, we got to divide that number continuously. Like let's say if we are given a number, we can call it x. So we have to divide x by from 2 to x minus 1. Right? This is the first step. The second step would be, if we get remainder equal to 0 for any number, we can be sure that the number is not prime, right? And then third, if remainder is not 0 for any number from 2 to x minus 1, we know that the number is prime. Okay, so initially it will look like a lot of work, like we want to write a program and why would we spend so much time in tackling this and stuff like that. But as you go on further, as the problem complexity increases, you would understand that initiating like this is why I have taken or I have spent time teaching you this even before I have jumped into programming language or writing actual code. Because if you don't have this logic, not logic about prime numbers, if you don't have this logic clear of how to develop logic, the logic of creating logic, like how do we know if a number is prime or not? If you can do it on paper, if you can do it on your own, in your mind, then you can obviously code. Now you just have to convert this thing into a language that a computer can understand. Now your mind has made you understand this thing, right? It is very easy. Your mind is made to understand this thing. Now you have to make the computer understand the same thing. So for that, we will write programs which will have its own syntax, its own rules. Syntax are nothing but rules. So that's it for today's lecture. We have taken 2 examples, and we can take more examples if you want. You can write it down in comments if you'd like to know more, if you like to, or if you like me to go through more examples. So now since this is done, in the next lecture we will start with actually installing the C compiler on various machines, on whatever machine that you have. It is very important to have a working laptop or a computer with you to actually learn. And then we will actually dive into writing code. But this again is very, very important. If you want me to take more examples like this, please write it down in the comments. Please let me know. If something is not clear, please ask me directly in the comments. Let me know. And again, now if you like this lecture, if you want to be notified of it, if you want to be notified of the upcoming lectures, then please click subscribe. In the next lecture, we will start with actual installing the C compiler, and then we'll move on to writing actual code. Thank you.